Assalamualaikum warahmatullahi wabarakatuh. Today we will talk about past year question discussion, okay, for chapter 2. So in this slide, I will pick a few questions from the past year and then show how to answer all the questions. Okay, so for the first past year, we'll talk about December 2018, question number 2. Okay, this question from chapter 2. Okay, so the question state that a student performed 4 titration of standard NaOH to determine its concentration. The volume of NaOH used as given in the following table. So we have 4 titration with 4 volume of NaOH. Okay. So the question for A, determine the mean, median and range of the data sets. And then B, calculate the standard deviation of the data set. C, using a suitable statistics test, validate whether the outliner should be rejected or accepted at a 90% confidence level. Okay, so I will show you step by step by question. So we go to the question A, determine the mean, median and range of the data set. Okay, so this is the data set. We have 4 data. Okay, for mean, okay, x bar here means for means equals to, okay, just take the value number 1, titration number 1, 32.6 plus with the titration with the volume number 2, 22.1 plus with titration number 3, 23.7 plus with titration number 4, 22.4 ml over 4 because we have 4 titration here. So means that we get 22.7 for the mean. Okay. So for the median, okay, question number 2 here, okay, ask for the median. So median, okay, first step you have to arrange the data first, okay. So arrange from lowest to the highest lah, okay. So the data from the lowest from data number 2, 22.1, okay, and then data number 4, 22.4, and then data number 1, 22.6, and then data number 3, 23.7. Okay, so median means intermediate between. Okay, so we have 4 data means between data number 2 and number 3 here. Okay, 22.4 plus with 22.6 over 2, so we will get 22.5. Okay, so for the range, okay, so for the range, the value that have highest value minus with the value with the lowest. Okay, so 23.7, okay, the highest from titration 3, 23.7 minus 22.1 from data number 2, so we will get 1.6. Okay, the answer will be 1.6. Okay, so okay, next question, we have question B. Calculate the standard deviation of the data set. Okay, so to calculate the standard deviation, usually we have to use the formula here. Okay, S equals to square root of total of deviation square over n minus 1. Okay, so in easy way to find the deviation, okay, we use the table here. Okay, so xi means the x for the data titration 1, 2, 3, and 4. Okay, so titration 1 we have 22.6, titration 2 we have 22.1, titration 3 we have 23.7, and titration 4 we have 22.4. Okay, and then we minus the data set here with the mean. Okay, so in question A, we already find the mean. The mean is 22.7. Okay, So 22.6 for data number 1, 22.6 minus with 22.7, so you will get negative 0.1. 22.1 minus with 22.7 will get negative 0.6. 23.7 minus with 22.7 will get 1. 22.4 minus with 22.7 will get negative 0.3. Okay, after find the deviation, we have to find the deviation square, because from the formula we need the total number of deviation square. So just 0.1 power of 2, so you will get 0.01. Okay, 0.6 power of 2, you will get 0.36. Okay, 1 power of 2, you will get 1. Okay, negative 0.3 power of 2, you will get 0.09. So the total will be 1.46. Okay, so from the table, okay, just put in the formula. So the S standard deviation will be, okay, square root of, okay, 1.46 from the table minus with n is means the number of data. So from the table, the blue table, we know that we have 4 number of data. Okay, minus 1 means it will be 3. Okay, over 3. So the answer of standard deviation from for this side is 0.698. Okay, so this is the final answer. Okay, so next we'll go to question C. Okay, the question states using a suitable statistic test, validate whether the outliner should be rejected or accepted at 90%. Okay, so of course you have to arrange. Okay, so the suitable statistic test. Okay, to 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 pick whether the outliner will be rejected or accepted, of course you have to do the Q test. Okay, so step for do the Q test. First step is arrange data in increasing order first. Okay, so we have 4 data here with 4 value. Okay, first arrange from lowest to the highest, and then we'll arrange 22.1 because this is the lowest. Okay, 22.4, 22.6, and 23.7. Okay, after we arrange the data, you have to identify the gap between the data. Okay, so the data number 1 and the data number 2, the gap will be 0.3. So data number 2 with the data number 3, the gap will be 0.2. Data number 3 to data number 4, the gap will be 1.1. Okay, so the highest gap, okay, the highest gap between the data 3 and 4, okay, so this one you have to suspect. Okay, suspect maksudnya reject or accepted because of the gap is so big. Okay, because the gap is not same with the other gap. Okay, 1.1. Okay, so the highest number between the highest gap, 23.7, this is the suspected value. Okay, this is the suspected value. Okay, so to find the Q experiment, okay, to find because we used Q test, so to find the Q experiment, the equation, the formula will be A. Okay, A is the highest gap over W. W is the value between the highest and the lowest. Okay, the lowest minus with the highest, that is W. Okay, so A here we get, okay, 23.7 minus 22.6, so the gap will be 1.1. Okay, for the W is the gap between the highest and the lowest value, so means 23.7 minus 22.1, so you will get 1.6. Okay, So 1.1 for A over 1.6 for W. So you will get 0.6875. So this is the value of experiment, or we call the Q for calculation. Okay. So to identify whether this Q value is accepted or rejected, so you have to look at the table. You have to compare with the Q table. Okay, so from the Q table, okay, how to look the table? You have to find number of observation. So number of observation is based on the number of data set. So from the blue table, so you know that the number of data set is 4, and then the value, the percentage that you want is based on the question, okay, 90%. So you have to look the value of the critical value for 90% confidence. Okay, so here we'll get 0.765. This is based on the table. Okay, so this table will be given in appendix, okay, during test or final. Okay, so means that Q calculation or Q experiment is lower than Q table. Okay, Q table means from the critical value here. Okay, so therefore if the Q calculation is smaller than Q table, so the suspected value 23.7 is accept. So we accept this number. Okay, we accept the number of 23.7. Okay, that's for C. Okay, next we go to the another question, December 2019, question 2 also. Okay, the question state that a precipitate of hydrochloride was titrated with silver nitrate solution. The final concentration was tabulated as follow. Okay, so dia bagi table here, we have 5 data here with different concentration. So for question A, by using Q test, okay, mentioned already Q test, determine whether the outline if the data should be rejected or retained at 90% confidence level. And question C, based on your answer on question 2A, express the confidence level of data set that can be reported at 95% confidence level. Okay, so we go by question A. Okay, using Q test is already mentioned here. Q test, okay, determine whether the outline data should be rejected or retained at 90% confidence level. So as usual, okay, you have to arrange the data first from lowest, okay, to the highest. Okay, so the lowest from data 5, 11.25, and then 11.30, and then 11.40, 11.50, last 12.70. Okay, arrange from lowest to the highest. Okay, then you have to find the gap. Okay, because you want to know what is the suspected value. Okay, so the gap between 11.25 and 11.30 is 0.05, and then gap between data number 2 and data number 3, 0.1, data number 3 and data number 4, 0.1, data number 4 and data number 5 is 1.2. Okay, so the highest gap is the suspected value. So the suspected value will be 12.70. This is the suspected value. Okay. Okay, so A will be 1.2. Okay, so W will be, okay, the highest of the data minus with the lowest of the data. 12.7 minus 11.25 equals to 1.45. Okay, and then just put in the formula, okay, A over W, 1.2 over 1.45. So the Q calculation, you will get 0.827. Okay. Okay. So after you calculate the Q, and then you have to compare with the Q table. Okay. So Q table, first you have to identify the number of observation. Of course, the number is 5 because we have 5 data here. So mean 5. And then the question asks for 90% confidence level. So you have to look for the 90%. Okay, so for the 90%, the value for Q table is 0.642. Okay, so that means that Q calculation is bigger than Q table. Is higher than Q table. Q calculation is higher than Q table. So if high, so the value for suspected value 12.70 have to be rejected. So this value have to be rejected. So no more value for table for experiment 4 because the Q calculation is higher with the higher than Q table. Okay. Okay, so for C, based on your answer, answer from question 3, express the confidence level of the data set that can be reported at 95% confidence level. Okay, so the question need to express the confidence level. So this is the step for confidence level. Okay, first you have to calculate the mean, and then you have to calculate the standard deviation, and then you have to check the T factor table. Okay, and then use confidence interval formula here. Okay, confidence limit equals to this one, and then write the conclusion. Okay. Okay, so the first step, okay, we have to calculate the mean. Okay, so the means, okay, you have to calculate all the data, okay, all the value 11.3 plus 11.5 plus 11.4 plus 11.25 over the total rate, the total number of titration is 4. So the means we will get 11.36. Okay, this is step number 1. And then we go step number 2. Step number 2, you have to find the standard deviation. Okay, to find the standard deviation, we use the table here. Okay, so you put all the data. Okay, we have 4 data. And then table number 2, you have to find the deviation. Okay, to find the deviation, the data minus with the mean. Okay, so 11.30 minus with 11.36, so you will get negative 0.06. Okay, and for data number 2, number 3, and number 4 is the same step with the data number 1. Okay, and then after you find the deviation, you have to find the deviation square. Okay, power of 2. Okay, so negative 0.06 power of 2 will get 3.6 times 10 power of negative 3. And then so on for data number 2, number 3, and number 4. So after you find the deviation with the square, the power of 2, so you total the number, so that, you will get 0.03696. Okay, so after that, you use the formula for standard deviation. Okay, S equals to square root. Okay, x I minus x bar square over n minus 1. Okay, so just put the value in the formula. After the formula, you have to remember. Okay, so 0.03969. Okay, 69 over 4 minus 1, because we have 4 data minus with 1, so we'll get 0.1109. Okay, this is step number 2. Step number 3, okay, you have to look the table. Okay, So to look the table, the value number, you have to identify the value number. So the value number is n minus 1. Okay, so the number, the n will be 4 minus 1. So the value you have to look is the value number 3. Here, okay. So the value number 3, and you have to look the value for 95% because the question asks for 95%. So the value is 3.182. So this will be, so t will be 3.182. Okay, so step number 3 is actually to identify the t. So the t have to be identified based on the table. Okay, so this table will be given on the test and also on the final. Okay, so step number 4. Okay, to find the confidence level, you have to use this formula, means, okay, plus minus t value time with s, standard deviation, over square root of n. Okay, so the mean, of course, you know from the step number 1, 11.36, plus minus, okay, plus minus t from the table, from the step number 3, 3.182 time with s, standard deviation from step number 2, 0.1109, over square root of n. N is the data set. We have 4 data set. Okay, so the answer for the confidence level 11.39 plus minus 0.176. Okay, so step number 5, we have to do the conclusion. So based on the confidence level, confidence limit, okay, 11.63 plus minus 0.176, it means that there is 95% chance that the true means lies from the range 11.184 to 11.1539. Okay, how you get 11.184 is based on 11.36 minus with 0.176. So you will get this value. Okay, to get this value 11.539. So 11 means that you have to plus with 11.36 plus with the value of 0.176. So you will get 11.539. Okay, so that's all for the past year question discussion. Okay, I hope you will practice with the from another question, past year question, because the pattern of the question is the same like what we discussed here. Okay, so good luck everybody. Assalamualaikum.